Hello everyone, we are facing the column analysis question number 1 in this part. Let's go over what is given in the question to us for the solution briefly, and let's move on to the solution itself. So we are given a cross section with double reinforcement. There is steel both in the tension zone and in the compression zone. The full height is given as 500 millimeters. The distance between the uppermost fiber to the center of the tension steel is given as 465 millimeter, and the distance between the two steel layers is given as 430 millimeters. What is also given to us is that there is an axial force of 247 kilonewtons. We are using C16 concrete, which the concrete design strength is then 11 megapascals. The steel grade is 420, with, of course, results in the yield design strength of 365. The steel areas in the compression and the tension zone are equal to each other with a value of 600 millimeters square, and we are asked to find the MR for the given structure. So in the column analysis questions, the first thing we need to check what is the mode of failure, if the structure is failing in the tension or in the compression. And in order to do that, we need to find the balanced axial force NB, which is the balanced case axial load. Okay. So in order to do that, we need to use the formula in our hand to calculate MB, and we have covered this in our lecture notes. And MB is formulated as 0.85 times FCD times K1 times C balanced times P. We know every value in here except the CB, which is the neutral axis depth for the balanced case. In order to do that, in order to find that, we need to draw a strain diagram and write the triangle similarity equation. So let's draw our strain diagrams. Okay, so this was our structure, our cross section, sorry. It is something like this, and okay. So here we go. This is the epsilon steel one, the strain in the tension zone steel, and this is the strain in the tension zone, in the compression zone steel, and this is 0.003 because the concrete crashed in the upper zone, and the strain corresponding to that is 0.003. So the first thing we need to do is to find the ESY, which is the yield strain for the steel. And how do we do that? We divide the FID with the modulus of elasticity of the steel. So FID in this question is 365 megapascals, and we know that the modulus of elasticity of steel, is 200 megapascals, and when you do the calculation, you get the yield strain as 0.001825. Okay, let's go back to our strain diagram and let's use this information for the triangle similarity. So this distance is CB, which is the neutral axis depth for the balance case, and we need to also have the D in our hand, which is the distance from the uppermost concrete fiber to the steel layer in the tension zone, and this was given as 465 millimeter in the question, as shown here. So having those values in our hand, we can write the triangle similarity as like this. CB divided by D is equal to 0.003 divided by 0.003 plus E steel yield. So let's plug in the numbers. CB divided by 465 equal to 0.003 divided by 0.003 plus 0.00, too many zeros, 1825. Okay, when we do the calculation in my calculator to find the CB value, we find CB as 298 millimeter. So since we have the CB value in our hand, we can go back to this equation and just rewrite that, since we know all of the values in our hand, to